Okay, this is lesson 5 in TK-TCL programming, and we're going to talk about mathematical functions and how to do math and arithmetics in TK-TCL. Now, we use usually this command named expression. Okay, so what I do is I'm gonna tell you how to add, how to subtract, multiply, divide, remainder, okay, to get the remainder of the division. Now, this is how we add. Okay, so we use expression 3 plus 2, okay, and this brackets, as we said, those square brackets will output the resolving of this command. Okay, so you'll have 3 plus 2. Now this is how you subtract using this dash, okay, and this is how you multiply. We have a star here, okay, and now we have a little trouble here regarding our little issue, small issue regarding the division. Now, if you put the number on the numerator, okay, as a non-decimal number, like here, okay, it will be, or it will give an output of 3 of an integer. Sorry, it will give an output of a complete integer. Okay, but if you put a 3.0, this means this is a decimal number, therefore it will give you 1.5. okay, we'll see that. Okay, and because there's a pause here, I made a pause here. Okay, and now if I want to get the remainder of the division of 3 over 2, you must have 1, okay, and 1 as remainder. You must have a division result as 1 and 1 as a remainder. So this is lesson 5 now, talking about, and here. So this is the addition. 3 plus 2 is 5, 3 minus 2 is 1, and 3 plus 3 times 2 is 6. Now see, 3 over 2, not 3.0, 3 over 2 is 1, but 3.0, okay, is over 2 is 1.5. So if you want to have a complete division, okay, use full decimals, okay, complete decimals, don't put just 3, okay. Now this is the remainder, 3 over 3 division 2, okay, must give you the remainder of this integer or Euclidean division is 1. Okay, now now I'm gonna tell you what's this remainder is useful for. This is what we call the modulus operator. Now if I set the division by as 3, for example, if I want to like use a 0 a modulus 3 until 10 modulus 3, okay, so look what will happen. Now I have a pause, should have a pause, yes, here, there's another pause here. So look at the way that over 3 things will be cyclic. Okay, so this is it. So it will be 0 1 2 0 1 2 0 1 2 0 1 2. So this way it will help you to cycle over things. Okay, because if you say 0 over 3, it's 0. 1 over 3 is a remainder of 1, okay, because there's a result 0, okay, and the remainder will be always 1. Now 2 will give you a remainder of 2, and there's a division result as 0, okay. So 3, look, for example, if you go to 8, okay, 8 over 3 is 2, and you get a remainder of 1. Okay, so this is how it works. Good. Now we want to get the square root, so puts root of number. So we got the number 2, we want to get the square root, radical 2. Okay, so we get this function sqrt and put the number between the parentheses. So I'll and get also if I want to get the power, okay, 3 power 2, which is 9. Okay, so I want to make here 2 to the power 3 as per the code. It will be 8. Okay, so this is how we use this function named pow, number and power. So the power is, for whom don't know, is like 2 times 2 times 2. So this is the power of 2 to the power 3. So this is 2 to the power 3 because it's a multiplication repeated 3 times, okay, over the same number. So I press enter and get the square root of 2 and the 2 to the power 3. So this is it. So 2 power 3, 2 times 2 times 2 is 8, and this is the root, 1.4. Okay, now if you want to go through logarithms, okay, use the exponential. Okay, so the exponential is this constant 2.7, which we call it e. Now the logarithm of e is 1. Okay, this is by definition. Now the log base 10 of 1000 is 3. Why? Because you have 3 it's the number of times you multiply 10 by itself. Okay, so 10 times 10 times 10 will be 1000. Okay, so those are if you count them 3 times. Okay, so this is how we get it, log 10, the number. Okay, now I want to go through a little bit of trigonometry. Okay, so the sine of, let's go through this a little bit in details. The pi is this number. Okay, it's a constant number. Not gonna go through deep math. Okay, just know that if I have a 100 degrees, okay, the angle which is a straight line, the 90 degrees is pi over 2. Okay, and sine 90 degrees is 1, and therefore a sine of 1 is pi over 2, which is 90 degrees. So to get pi, okay, multiply a sine 1 by 2. Okay, so this is how you get the pi, the exact numbering, or the exact value of pi. So it's arc sine. The a sine is the arc sine, which is the opposite of having like if you say I have the sine to get the sine of angle degree 90 degrees, sorry, of the angle which is 90 degrees, I get 1. If I want what's 1 for the arc sine, which is the opposite, will give you the 90 degrees. So this is how, okay, as by definition the pi over 2 is 90 degrees. So this is how you get a pi. So if I want to get the sine of if I want to have the angle 30 degrees, it will be pi over 6. Okay, 180 over 6 will be 180 degrees over 6 will be 30 degrees, which is pi over 6. Okay, because here we deal with radians, we don't deal with degrees. Okay, now sine of this angle, the 30 degrees, must be half. Okay, okay, so this is the sine of this angle. Now the cosine must be radical 3 over 2. If you calculate it, it will give you this one, and the tangent will be the sine divided by the cosine, and you get the tangent, so it will be this one. Okay, now moving on to something else, which is if I have a decimal number like here 2.34. Okay, I want to get what's the next exact integer, okay, bigger than 2.3. So I use the command here, floor. It will give me 3. No, it will give floor gives you the previous integer. Sorry, previous integer. Okay, so if you have a 2.34, okay, the floor gives you the floor, you know, the bottom line, okay, which is 2. But if you get the ceiling of decimal, which is the top of the top or the next integer of 2.34, it will be 3. So look at the results here. So this is the floor, which is 2, and this is the ceiling, which is 3. So what's before the decimal area, the exact number that's just before the decimal area, and what's after the decimal area, next decimal area. Okay, and this way you can calculate calculate and separate the decimal part of the number. So by getting the decimal and subtracting the floor of the decimal. Okay, and that's our lesson. Thank you for watching.